Silence! Thank you, Chase. That was just a chase, really. I'm sorry if I scared anyone else. Okay, so today I'm going to be talking about intro to SDR, or software-defined radio software, and then my Discord emergency services bot. All right, so who am I? Hi, I'm Dan. I'm from around Hartford, Connecticut. I did some research at University of Connecticut. That was one of my past presentations, actually. And then I like wireless and hardware, and those are my two dogs at the bottom. Yeah. All right. So what is an SDR? Basically, like your car radios. So take that car radio. It does a whole bunch of things internally, which I have on the left there. And everything that it does with demodulation, so reading in radio waves, it'll convert it so that you can actually listen to it. All of that stuff is done with actual hardware, whereas with a software-defined radio, you do it through software. Pretty simple. Yeah. All right. So I use the word modulation there, but this is kind of the idea of what it is. So on the left side here, that's like the message that you would want to transmit out. In order to get it so that you can actually send it out through like radio waves, you have to do something called modulation. So you need a carrier signal down here so that you can get it into like a waveform that can be sent through a transmitter. So yeah, and then once you receive those signals, you need to demodulate it. So just go in reverse. Yeah. Okay, so a couple of types of SDRs. I just put these two up because they're the two that I have and that I'm the most comfortable with. So the RTL SDR is like $30. It's a really good starter one. It's the one that I started on a couple of months ago. Really good, but it is receive only, and the band that you can receive on is only 500 kilohertz to 1.7 gigahertz. So if you want to look at Wi-Fi traffic, you would need something like a Hack RF1. So a SDR that can receive upwards of 2.4 gigahertz, since Wi-Fi is on 2.4 gigahertz or 5 gigahertz. So also, additionally, the Hack RF1 can transmit and receive, and it has a way higher sample rate. Also, just some other ones that I put up there, other popular ones. The Pluto, AirSpy, and Line SDR, those ones are fairly expensive. Definitely much more expensive than RTL SDR, but they have a lot more capabilities, similar to the Hack RF1. Okay, so the first software that most people will probably start on is like a frequency analyzer. There's a lot of free ones out there. This is just 3 of them. So SDR++ is my personal favorite. So because it allows you to save frequencies that you want to listen to later. So if you were on this, and all of these bumps right there, those are like radio signals. So think like a radio station like 89.7. That's just off my head. I don't know if that's a real one. But think like a radio station like that. You tune in, take all of those samples, demodulate them, and then listen to what's being sent out. Typically, music or like people talking in a podcast format. So with SDR++, you can save the signals, and then with the other two, so SDR Sharp is this one up here. I know captions are kind of covering that, but that one's very, very similar to SDR++, just you can't save frequencies. And then GQRX, the Linux version of this stuff, even though I'm pretty sure you can download SDR++ on Linux as well. But GQRX is, I haven't used it because I don't run Linux daily, but I've heard good things about it. All right, so breaking down SDR++, sorry that the screenshot isn't nearly as good as the last ones, because I just did this in this building, and as you can imagine, the frequencies that I get, they're not that great because, bricks and like Faraday cages and whatnot. But up here, this top section right here, that's where we have our FFT, so fast Fourier transform. You're taking in all of the samples, and you're basically showing where the signal is the strongest. And where the signal is the strongest is typically where you're going to have a radio station. So that's where you would want to tune into. Then the waterfall. So if they're not talking, if someone isn't talking constantly, you can't see it on your FFT section, you would be able to see it on your waterfall. Whoops. Yeah, there we go. You'd be able to see it on your waterfall, and the waterfall, basically just anything that's not blue down here will be like a strong signal a few seconds ago. So settings, this is the fun stuff. This is where you can change like from FM to AM to, in some other ones, like police talk radio, that type of stuff. And you can also use squelch, which is another useful setting. Basically, if the FFT isn't getting a signal that's under a certain threshold, it won't allow you to listen to it. So instead of just hearing static, you'll hear nothing. That one's pretty useful. And then at the top up here, your current frequency. So you can tune that in order to change where you're taking all of your samples and where you're actually listening to. All right. So fun one that a lot of people use is Universal Radio Hacker. So what Universal Radio Hacker is for is like demodulation and reversing wireless protocols. So think like you have your car key fob. You click the button and it sends out a signal to your car, and if that signal matches something in its database, it'll unlock. Same with the garage key or the garage door opener. It'll send out a signal, and if that signal is the one that the receiver is expecting, it'll open the garage door. And one really good example of that is right here. So this is from a guy named Sammy Kamkar. He's really good. He's a security researcher. You should go check him out if you're interested. And he actually did what I was just talking about. So he took his garage door, and the way that a garage door opener actually works is you have 10 pins on the inside that are either on or off, and you need to match that with the receiver. So, which that would be, 2 to the power of 10 codes. So fairly decent amount of codes, but you can break it pretty easily. And he was showing that when you click that garage door opener, since it's only 10 bits, you can pretty easily see what is a 1 and what is a 0. And he marked that there. And from this, he was actually able to take this code and just like replicate how that is being sent out, and just run through like all of the possible combinations. So like 0000000, 0000001, and then so on all the way until he covered all of them. And he was able to get his device to open any garage door within like 10 seconds. Really impressive. All right. So another one, RTL 433. So 433 megahertz is the main frequency that's used for IoT devices. So like your wireless lights that you can turn on from a remote, that type of stuff. A lot of people have them in their house. That you can capture all of that traffic through this application RTL 433, and then it outputs it in it checks databases, and it outputs all of the information that's also being sent through that. So like the battery level, the exact frequency that is being sent on, the ID, the time that it was sent, and the type of modulation. So yeah, that's pretty interesting. If you want to, spy on your neighbors, I guess. Okay, Dump 1090. Too bad Kenny's not here because he really likes this one. So Dump 1090 basically, planes, when they're flying overhead, they beacon down signals telling that are typically for like air traffic control, telling them where their exact position is, their altitude, and that type of stuff. And then you can actually, like with that cheap like $30 device that I showed, RTL SDR, you can actually catch that traffic, and then Dump 1090 takes it, puts it onto this like this table here, and then actually used to be Google Maps, but the Google Maps license actually ran out, so they use something else now. But you can plot it on a map and see actually where all of the planes are. Pretty interesting. Okay, so getting a little bit more into the weeds here, GNU Radio Companion is software that's used. It's basically just to group Python libraries that are out there in order to do specific things that you want. So what I have up here in the flow graph section is actually just like what I had before. Let's go back. It's basically just a frequency analyzer. So if you actually ran that GNU Radio Companion code, you would be able to see something kind of like this. You got the waterfall, and you have the FFT in a few settings, although not nearly as good as SDR++. Yeah. So that's what I have there. And then you also have all of these block libraries. Basically, you go into those, pick the blocks that you want. It's kind of like Scratch coding, but a lot less fun and more frustrating. So, but you can do much cooler stuff with it. Like, for example, you could, another video that I saw was someone actually used Universal Radio Hacker to take in some signals of a car key fob, and then from that they were able to make or replicate that code and make a GNU Radio Companion to send out, and make a GNU Radio Companion set of or flow graph to actually send that code out and unlock the car. So kind of what Chase was talking about with the Canadian government trying to ban like flipper zeros and other SDR devices. This is kind of how that would be done, even though really no need to worry because modern cars have a set of security measures that won't let that happen. Okay, so all of these like SDRs, they all have their own Python libraries. So like HackRF is the HackRF1, and then RTL SDR. So you can go and download these, look at the library and everything that it can do. And if you have like another SDR, I imagine that you could just type into Google your SDR name and then Python library, and that's how I got all of these. Okay, so before I move on to my Discord bot, does anyone have any questions? I know that was kind of a lot. Yes, Zach? This last part, he clearly wasn't here. I was just talking about how much this could be used offensively. What do you want to hear about, Zach? Defensively. That's actually a much better question. So, defensively, this type of stuff, you could use it for like hardening systems, like rolling codes in cars. So rolling codes in cars basically just means that every time it sends out a signal, it increments the code that it's going to send out by some certain amount. So it has a database of codes that it will send, and then the car has the same database. So every time it sends a code, it crosses it off, and it will never send it again. That's a way that this can be used defensively. Okay, so my emergency Discord bot. I used some of the techniques that I talked about earlier and my RTL SDR in order to make a Discord bot that would alert me every time basically RIT emergency services were called. So, like I said, the tools that I used, I got like this $20 antenna off of Amazon. Then SDR, and then my Raspberry Pi right here. Pretty inexpensive stuff, honestly, but got the job done. All right, so first thing I needed to do was find out what frequency RIT Emergency Services was transmitting on. So you can go over to this website called Radio Reference. Very useful. They have it's basically just like a database of all of the radio frequencies that are used, or that are like that are used for example, EMS. Companies have some, federal government, military, schools, emergency operations. Basically, anything that can be publicly known is on Radio Reference. So I took the RIT Emergency Ops frequency, which is 461.425, and then I went from there. So I know I mentioned what the Fourier transform is. Basically, it's just, it's a mathematical operation used to visualize or find the strength, or some people call it the power, at a given frequency. And does anyone have any idea why I would need that? Philip?
Did you see a spike in power on the baseline? It shows that someone's broadcasting on the frequency.
Exactly. So Philip said that if there's a spike from a baseline, that there shows that there's some activity on that frequency. And that's exactly right. So you can use for the Fourier transform, or in my case, there's a Python library, fast Fourier transform, which is used more generally because it's fast, and faster is typically better. So, yeah, the general concept here is that I take in the raw data, and then I use the FFT to extract like the power. So I extract the power of at any. I think I did it like every 2 seconds for however long I was doing it, and then you take the center of the frequency I'm listening to, and that basically, since I'm taking, it was 2.4 million samples at the time. Really all I care about is the center, so that center frequency that I was listening to, that's the one that I'm honed in on. So that would be the 461.425 that I was talking about earlier. So I would just take the center of all of my samples, and that would be the exact frequency that I was looking for. So basically, I tested against this threshold to see if there's a spike, and that threshold typically takes some tuning. So it's not going to be the same for everywhere that you're doing this. If I'm up in my dorm room, I'm on the 6th floor of my building, so I get a pretty good signal up there. But if I'm down here in a Faraday caged building, I wouldn't get nearly as strong of signal, so that threshold would naturally be a little bit lower. Yeah. So when I do that, I used a webhook in order to send a message from my Python script to my Discord channel. Yeah. So some of the code here. There's my target frequency, like I said, 461.425 megahertz. That's what the E6 is. The E6 is just a 1 million multiplier, so mega. Yeah. Then my threshold, it was kind of like, as I was doing this, it was kind of like random numbers. It wasn't exactly like what you would think. It wasn't the decibel range. So typically with decibels, you would expect like a negative number. A spike would typically be around like negative 20 decibels. But that wasn't the case. And my threshold ended up being like 3. And that was, I think it was just like the height from the baseline. And 3 worked out pretty well, because anytime it was above that, that generally meant that it was a pretty strong signal. And so I'll get into this in a second, but that PSD function is how I was able to. That was from a already established Python library. I didn't actually write that, and it's for the fast Fourier transform integration. So that's actually where the meat of the program is. Okay. So this PSD function basically it takes in the number of data points used in each block for the fast Fourier transform. So it can't do it all at once. So my it couldn't do my 2.4 megahertz all at once. It had to do it in chunks. And 1024 was just the amount of data points that was used in each of those. Then the sampling frequency, basically, that's my 2.4 megahertz. And so it takes in not megahertz, but it just takes in like it doesn't take in the hertz values, it takes in the megahertz. So I had to divide that by 1 million. And finally, the center frequency is the FC value. So that's basically just that's the frequency that I was listening to. So this is what the plot would actually look like. And I'm pretty sure I did this with matplotlib. So anytime, who can tell me what frequency I was listening to and why this triggered? Chase, why did this trigger?
Because there was a lot more stuff happening.
There was a spike in the data. Yeah. Is that what you're going to say? Yeah. So it basically just means that there was an event here. People were talking on that frequency that I was listening to. And if you don't know, 119.55 is the frequency for air traffic control, the air traffic control tower at the Rock Airport. So I was just using that as a test case because they pretty much talk on there like every 5 minutes. So if I didn't get anything over like a 10-minute period, I knew that it wasn't really my threshold was too high, and if I was getting something like every few seconds, that pretty much just mean that my threshold was way too low. Yeah, so this red right here, that is where it finally triggered in that center, that huge spike at 119.55 megahertz. That's what triggered my Discord bot to actually send a message. Yeah, so if you haven't seen any like Discord webhook integration, basically you just take in like a link. So I blurred it out on here, but down here, this link, it starts with HTTPS and then Discord API webhooks, and then you have like it's like a private key for your exact Discord or Discord channel, and it'll just like send a message into that exact channel with a certain ID that you also have in that link. So this takes in that webhook URL, and then anytime that it's called, it'll send a message with the exact date. So yeah, it'll post, yeah, response post webhook URL, and yeah, that's how that works. And whoops, actually, this emergency service is called at 23. That's like 11:25 p.m. So something was going on that night at RITSEC. I don't know what it was, but I know something was going on. All right. Any questions? Yeah. Yes.
So I'm kind of new, like kind of started with Raspberry Pi, but looking at that with Raspberry Pi, do you have any like a good like starter projects to just like try to get used to the
Like navigating Raspberry Pi.
like working with
So working with the Raspberry Pi, you could just familiarize yourself with like the syntax for. I mean, it's like Linux, so just familiarize yourself with Linux and the operating system in general, and then from there, a starter project, good one would probably be just like I don't know, downloading software or like running just like a frequency analyzer like GQRX that I talked about earlier. That would probably be good. Will.
How do you avoid accidentally doing illegal things with your frequency?
Okay, this is actually a good thing that I probably should have mentioned. So, there are two things that are illegal with your like SDR. There are two things. You cannot transmit data unless you have unless you have a certification. So you need to go through a course. Yeah, Philip.
I was gonna add on the go.
You go. Feel free. Go ahead.
There's one or two public bans where you are allowed.
Oh, okay.
Very limited.
Yeah, I fair. Okay, so there's two public bands where you can, but in general, unless you have a ham radio license, you cannot transmit frequencies. But you can receive all you want. It's pretty much completely legal to do that, except when you're receiving like encrypted police talk radio. You are not allowed to decrypt those messages. That's also legal. So, that answer your question, Will? Okay, this is good. Any other questions? Chase?
Oh. Speaking of questions, I mean, I guess I may have something in my head that it kind of looks like an SDR, but
It looks like a small SDR.
Yeah, I don't think it's an SDR. You know what it could be?
Could it be a flash drive?
I think it could be a USB. That's what I was thinking.
Thank you, Chase.